Hello Eng1060. In this video, we will cover the while loop and the break and continue functions. A while loop is used when you do not know how many iterations you require. Instead, you have a condition that you want to meet. The syntax for the while condition is while your condition, for example, a being less than 0. If this is true, then it will run the commands before ending. The commands block will be repeated as long as the condition is true. This means that you must ensure that your condition becomes false, otherwise you'll be stuck within an infinite loop. Here we have an example where we are decreasing n by 1 until n is less than or equal to 1. We're starting off with n equals to 5. Our condition is that while n is greater than 1, we want to run the conditions within the block. So first off, we want to display n, which starts off as 5, and then subtract 1 from n, so n will then equal 4. It rechecks the condition. 4 is greater than 1, which is true. Therefore, it will display n as 4, and then n is equal to 3, and so forth. Running the code will output the following: 5, 4, 3, 2. Since the condition 1 greater than 1 is false, it will not display n and subtract 1 from n. In the next example, we are increasing n by 1 until it is less than or equal to 1. Again, we are starting off with n equals 5. So while n is greater than 1, we are using the same condition. Then we are displaying n and then increasing n by 1. So 5 greater than 1 is true. Therefore, it will display n, which is 5, and will update n to be 6. In the next iteration, 6 is greater than 1. This is true. Therefore, it will run the commands, display 6, and n is equal to 7. So you can see that n is being increased every time, and our condition of n being greater than 1 will always be true. Therefore, we will encounter an infinite loop, whereby we can press Ctrl C in the command window to exit the code. Note that the error that pops up is that the operation is terminated by the user. As another example, we want to continue to multiply x by 8 until x squared is larger than a particular number, starting off with x equals 1. Here we have x equals 1. We have our iteration starting off with 0. And our condition is that x squared must be less than some large number. As x starts off with 1, x squared, which is 1 squared, is less than that number, therefore it is true. It will then go into the loop, update iteration, so iteration is equal to 1, and x is equal to 8. In the next iteration, 64 is less than 1, 2, 3, 4, 5, 6, 7, 8, 9. The next iteration is now 2, and x is equal to 64, and so forth. This will continue on until x becomes larger than 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the printout in the command window using fprintf. Here we have a code that will run into some issues. We have x is equal to negative pi, n is equal to 1. Our condition is while x is less than or equal to pi, we're updating y of n. with an absolute value of cos x. We are then plotting the result at the end. So what's wrong with the following code? A hint is to have a look at how the variables are being used and or being updated. Recall that our while condition, x less than or equal to pi, must be false at some point in order for the code to stop. Since we are not updating x anywhere, this code will be stuck within an infinite loop. Recall that we had our Pythagoras code where we were able to exit the code if a user entered a negative number for one of the lengths. So we have an adjacent length as a user input and opposite length as a user input. Instead of using if statements as we used previously, so if adjacent length was equal to 0 or if opposite length was less than or equal to 0, we can now instead use the while condition. So while adjacent length is less than or equal to 0, we can re-ask the user to input a positive length. The difference between the if statement and the while statement here is that the while statement will continue to check whether the input is a positive length, whereas the if statement will only check it once. So to recap, a for loop is used when you know how many times you want to repeat a code. The syntax is given by for. Some counter is equal to a vector. The length of the vector determines how many times you want to repeat the code. A while loop is used when you know what condition you want to meet. The syntax for that is while condition and then have your block of commands. It is important that you use the loop that is most appropriate for your task. Just like if statements, loops can also be nested. As an example, we want to print a 10 by 10 grid of numbers that count from 1 to 10 in the first row, 2 to 20 in the second row, and 3 to 30 in the third row, and so forth. We can do so using two for loops. This is the first for loop, counting from 1 to 10, and the second for loop also counts from 1 to 10. So what this will do is it will start off with x equals 1, y equals 1, and multiply the two together to give you 1. It will then go to y equals 2, x still remains as 1, so y times x is now 2. We'll then move on to 3, 4, 5, all the way to 10. Once it has reached 10, which is the final value of our counter, it will then go back outside and update x to 2. Y then restarts at 1 and gets updated to 2, 3, all the way to 10 throughout its iterations. The result is this in the command window, where we have used fprintf to print the product between y and x. It is often more useful to store values in a matrix rather than printing it out in the command window. This allows us to use the matrix for calculations and can be achieved by using the counters as indices. So considering the previous example, we can now, instead of using fprintf, store the values in a matrix called M, and we are addressing the x and y as indices. We're treating x such that it is our rows and y such that it is our columns. This is the resultant output. So we have 10 rows and 10 columns. For each element, we are simply multiplying x by y. It is possible to terminate a loop or skip an iteration. The break command terminates both for and while loops. Commands after the break will not run. In nested loops, a break command will only break out of a single loop. For example, if we had for end, and we had a break command in the nested loop, it will only break out of this loop here. It will still continue to run through the outer loop. A break command should only be used to handle unexpected situations. But do note that a well-coded program will not require the break command. The continue command skips an iteration. Commands after the continue command will not run. So I'll now go through an example of both the break and continue commands. When reading an unknown number of lines from a file using fgetL, the end of the file will be reached unexpectedly. Recall that we can open a file using fopen, extract data from a file using fgetL, and then close the file using fclose. In this example, while 1, which is also while true, meaning that this loop will never become false. It will continue to run the fgetL command to extract lines of data from the file. It will then store the data as a number into a variable or matrix called data and update n accordingly. Recall that fgetL returns the number -1 when the end of the file is reached. Therefore, we can include an if condition. If temp, which is our variable for fgetL, returns a -1, then we can break out of the while loop. This will then jump to fclose, where it will close the file. A continue example is shown here, where we have an x vector. We are pre-allocating y to be the size of x filled with zeros. So essentially it is a vector filled with zeros. We are then stepping through each value of x, which starts off as -10, -9, -8, 9, 10. And we're calculating 1 divided by the element. So for the first instance, it will be 1 divided by -10. Then in the next iteration, where n is equal to 2, we are saying it's 1 divided by -9, and so forth. You should note that we will encounter a calculation where we will have 1 divided by 0, which is not possible. Therefore, within the for loop, we have an if statement stating that if x of n is equal to 0, then we can continue. When the continue command is encountered, it means that it will skip the remaining commands in the for loop. So it will skip this calculation and start the next iteration. The result of the following code is shown on the right hand side, where we have 1 divided by x for most of the values except for x equals 0, which was a pre-allocation from y equals 0. So in summary, in this video we covered while loops, which are used when a condition needs to be satisfied. Just like if statements, loops can be nested for more complicated programming. And the break and continue commands can be used for more loop control. As a final thought for this video, is it possible to have a for loop within a while loop and vice versa?